when I was 16 and I learned about radians, in which 90 degree becomes pi by 2, 180 degree becomes pi, and so on. I wanted to know why when you know have something like sine of x or sine of theta and you put 90 degree into that, and we know by experience that if when you write sine of 90 degree you should write 1, but then if you expand sine into some Taylor series, which is what is it for sine, it's it has to be 0 in the beginning, so there's no constant. So let's say if it's let's say sine x equals x, it can't be odd, so it must be x square by 2 factorial minus x raised to 4 by 4 factorial and so on. No, wait, it has to be odd because sin x is an odd function. You should start with x minus x cube by 3 factorial plus x raised to 6 by, wait, what? No, 5 by 5 factorial and so on. You can expand sin x like this, and now my question was, why, I mean, if you put 90 degrees in here, this obviously makes no sense, but then why do you put radians into here, which while not entirely arbitrary also seems like a choice for units, but then they seem to be the natural choice of units, because once you put it in here you get the proper value of sin x that you want. And the answer to that is as follows. If you want to plot a graph of sine of x versus x, now we understand x as an angle, but how do you know in real life increase an angle? You can think about distances. So sin x is defined to be the length of this vertical bar when the length of this bar on a unit circle, so this is 1, is x. So when this length is x and this radius is 1, length of this bar is sin x, and so you have sin x that looks like this and so on. Now here is the secret. The x that you're increasing along this direction is increasing like this. So for when x reaches this value, if the radius of this circle is 1, then you would have reached x equal to pi by 2. No cap, like legit. Pi by 2, 1.57 whatever. And if you're measuring in meters, then meters. So when we write pi, it looks like something mysterious is happening, but it's just 1.57 dot dot dot. That's the logic. Now you can ask, what if it's not 1 but like let's say 5? In that case this wouldn't be pi by 2, this would be 5 pi by 2. And would this work? Well, it would work, but then the definition of sine would have had to change to mean that the length of this thing when the radius of the unit circle is 5, so it's a 5 unit circle. So in that change definition of sine it would work, but for this definition of sine it wouldn't work. You would have to scale it by 5 exactly, like it would be just 5 sin x. Okay, and another question, is there any way I can still plug in 90 into this and get the right answer? And the answer to this is you make the radius of this circle equal to 180 by pi. If you have that big gigantic circle and then you go 90 meters or whatever along the arc length, then when you put it into here, except that here you have to change the definition of sine a little bit. It wouldn't just be sine x, it would be sine x by a, where a is the length of the circle along which you are measuring things, and in normal case this a is 1, but in our case it would be 180 by pi. Of course you can see that I worked it backwards. Okay, thank you.